All right, volume, day 2, washer method. Okay, the reason that washer method is different from yesterday, the disk method, is that disk is a totally solid thing. There is just one big volume. Washer method, there's something hollow inside, okay? All right, so for example, if I have something like this, and then I have something like this, and this creates an area, and I'm going to rotate it around this axis. This is going to turn out looking somewhere like this, right? Let me draw something that looks more regular. Sorry. Okay, how about something like this? This is an area. Gonna rotate it around here. So, like that. Is the drawing that bad?
Yeah.
It's like a hollow cup. Yeah, it's like a cup. So it has some kind of like angle to it, but it has thickness. Okay? All right, anyways. So if you were going to do this, the area is going to be different because if you look from the side, it looks like a washer. So the question is, how do you figure out this area? What's the area of this shape? There are now 2 circles, right? One is on the outside, one is on the inside. So what is the area of this, just that outer ring?
The outside minus inside.
Outside what minus inside what?
Area or bound.
Area of the area. What's the area of that?
Like total minus
Pi squared minus pi squared. Pi r1 squared minus pi r2 squared.
Yes. Okay. So we have 2 circles, and this, let's say this is the outer radius. Let's say is r outer, so r_o, and then this is the inner area. Inner radius. Let's say r_i for inside. The area that is shaded is going to be the area on the outside minus the area inside, right? So that is pi r outside squared minus pi r inside squared. Yeah? So then we just factor out pi. So this is r outside squared minus r inside squared. Okay, so that is the area of that ring. And then we're going to take that ring and then integrate it so then we can figure out volume. Okay, so pretty intuitive. All right, so let's just try some problems. You just have to be, able to figure out what's the radius outside, what's the radius inside. Okay, again, these are all just kind of long problems, but just write out the important parts. Y equals x squared. We're going to revolve it around x-axis. Y equals x squared. We're going to revolve it around x-axis. All right, draw a picture. Y equals x squared. We're going to rotate it around x-axis. Okay, this is going to look like this. So if you look at from the front, it's going to be a really, it's like a cone with some kind of curve inside. Windows not convinced. Okay. It's like, no. Okay. What's the outside radius? Y equals x. So just x. And then what is the inside?
X squared.
X squared. Okay, so the area is pi r outside squared minus r inside squared. That is pi x squared minus x to the fourth. You guys all good? Easy. Okay, so now volume. Which direction are we integrating? X or Y?
X.
Very good. X direction. And so it's from x equals what to x equals what?
0 to 1.
0 to 1. Okay, x squared minus x to the fourth dx. All right, go ahead and figure that out. Sorry, I forgot the pi. So take the pi and put it outside. All right, 2 pi over 15. How many people got this one? Okay, all right. Let's skip the next one then. The next one is equally easy. Let's go to this one. Find the area, volume bounded by y equals x, y equals x plus 1, y equals 0, y equals 2 around the y-axis. Okay, draw a picture first. Okay, so this picture looks like this. What is it? X equals 0, y equals 2. So that is this part turned around on the y-axis. All right, so since we're going around the y-axis, which direction are we going to integrate? X or y? Y. So what is the radius on the outside? What is the radius on the outside?
X.
No, not x. We're integrating in the y direction now, right? So we're looking from the left to right. So that is y. All your equations have to do with y. Okay, please be careful. Okay, so what is the radius inside?
1 minus 1.
Sorry, y minus 1, yeah. Okay. And so area is going to be pi y squared minus y minus 1 squared. Radius outside square minus radius inside square. Okay, volume. We're integrating from where to where? 0 to 2. Okay, so in the y direction, okay? 0 to 2 pi y squared minus y minus 1 squared dy. Okay, go ahead and try that. Let me know when you're done. Okay, answer is 2 pi. Okay, you guys are getting really good at this. Let's try another one. But I feel like you guys are too good. So let's do any axis. Okay, not just x-axis, not just y-axis. We're gonna revolve it around any axis that is vertical or horizontal. We're not gonna do slanted axis. The region bounded by y equals x squared, revolving around y equals 2. All right, draw a picture. Okay, y equals x squared. Okay, y equals 2. It's not where they intersect, okay? Please be careful. That's not where they intersect. Y equals x and x squared intersects at 1. Okay, so then this is this part trying to revolve around this line on the top, so like that. Sorry, my drawing is getting worse. Okay, what is the outer radius? Let's talk about outer radius. Outer radius is this thing. What is the length of that outer radius?
Just X.
Outer radius, the outside one.
2 minus X squared.
Yes, 2 minus x squared, not just x squared, okay? We are not revolving around x-axis. We were able to get away with just x squared before is because we were just subtracting 0, right? If it's just the axis, it's just y equals 0. That's why we just use the function. But if you look at this whole thing from the top down, you know, you always look from the top down. This whole length is 2 minus this curve, which is 2 minus x squared. Okay, so r outside is 2 minus x squared. So then what is the inside radius? 2 minus x. Okay, when you're not revolving around the x-axis anymore, you will have a difference of the two curves for each radius. Are you guys good? Okay, so then area is equal to pi, and then this is going to be a little complicated because it's so much longer. 2 minus x squared squared. Shouldn't we be using y? Ah, great question. So we are revolving around y equals 2. Right, it's parallel to x-axis. Okay, minus 2 minus x squared. Volume. Volume, we are integrating from where to where? This is a little tricky. From where to where?
0 to 4.
Between wherever the area is, right? So between 0 to what? 4? Why 4? 1. 0 to 1. Why is this getting stuck? Okay, so go ahead and figure out the answer. All right, so for this area, you want to just multiply it out and simplify. You should get pi times x to the 4th minus 5x squared plus 4x. Okay, and then integrate that. You get 8 pi over 15. Okay, please be careful. One of them is a 2 minus x squared squared. The other one's 2 minus x, so they're not the same. You shouldn't get the same result when you square them. Okay, let's try one last one, and then you can start homework. Bounded by y equals x squared, revolve around the line x equals -1. This one, but this time we're going to revolve around x equals -1. So we're going to go this way. Okay, so if we're going to go this way, then r are going to be in terms of y, because we're going to integrate along the y-axis, which means we have to look from the right to left. That means we do need to change all our equations to x equals. So x equals y, x equals square root y. So the outside radius is square root y minus 1, so plus 1. Okay, and then our inside is going to be y minus 1, so plus 1. Area is going to be pi, the outside one squared, minus the inside one squared. And then you can probably do the rest. Okay, so try it and let me know when you have the answer. Okay, the volume is pi over 2.